So as our goal is to not just teach kids stuff, but to teach them stuff that they can use in a meaningful way, we're often thinking about how do I help my students take the knowledge from my classes and apply it into other classes or in general skills in life. Okay. So how do I facilitate transfer? What can we do? The book talks about strategies in which we can facilitate transfer. I focus on primarily four of them. First and foremost, that's going to facilitate transfer of knowledge is automaticity or overlearning stuff. The more that you are able to learn stuff where it becomes second nature, where it becomes easily accessed, easily retrieved, you don't need to think about it. It's like your times tables or dividing or adding, that stuff. We overlearn that material because as math gets more complicated, I don't need you to start slowing down, thinking about what 7 times 8 equals, and it slows everything down. I need that stuff to be automatic. I need that to be an overlearned skill to facilitate the transfer of knowledge into other mathematic operations. Okay. Secondly, we want to emphasize meaningful learning. The book talks about doing some of those KWLs. What's your knowledge? What do you want to learn? They talk about and they give you a little chart, the KWLs. Okay. So what does that mean? What do I do to facilitate transfer when it comes to emphasize meaningful learning? I have to encourage Q&As. I have to encourage lots of questions, provide them lots of opportunities for practice. I need to answer them, etc. Okay. By doing lots of that stuff, I'm creating a meaningful learning set. Other things that we could do, use of analogies. Sometimes students don't understand an explanation in one format. What do? Use other analogies. Use other examples. Make connections between something that's happened in the past and what we expect to see going forward. We use a lot of historical events as a means to explain current day events in history, social studies, and stuff like that. Science, how one principle in science is used here and how it's going to be used here. If you're understanding of the relationship between temperature, volume, and stuff like that, if we can use it in this setting, we can use it in other settings. All right. Hands-on activities, physical experiences, helping students make connections with the material in a hands-on manner is going to facilitate the transfer of knowledge. Keep in mind time. I know the clock is always ticking. Students want things to go by fast. Teachers want to move on to other subject matter. But when you want knowledge to transfer previously learned information to future events, you have to give it time. It just doesn't happen. It is an exercise. Things that we do more often requires time. And then lastly is teach good metacognitive strategies. When students are studying, when students are preparing for an exam, when we want students to be able to think about in the future what they can do, and a lot of students rely heavily on memorization and flashcards and stuff like that. Well, that only works for so long. Eventually, you start getting into content areas that require higher order critical thinking skills, things that require application, things that require elaboration, and those flashcards only limit or only work so effectively. So we have to start helping our students see that certain strategies will work more effectively than others and giving them those strategies and the time to develop that. So transfer of knowledge requires a lot of practice, a lot of meaningful experiences, a lot of time, and then developing more effective strategies. Okay, so our goal is to help that knowledge transfer from one content area to another, from school to outside of school. One other area that we hear a lot of in education is we want our students to be critical thinkers. We want our students to use higher order thinking skills. We want our students to be problem solvers. I hear that all the time. And then I wonder how many teachers really spend the time helping students develop higher order thinking skills, problem solving skills. We don't see a lot of it. Okay, we see a lot of do as I do, replicate, get ready for the test, get ready for the quiz, get ready for the performance assessment, and do it like I did. Do it like I taught you. Well, outside of life, outside of school, I should say, many things that we encounter for the first time, we don't have those skills in place. So when we talk about higher order thinking, a benchmark to a lot of, I should say a benchmark, but a lot something that many teachers will talk about. We're talking about more advanced cognitive processes that include integrating facts, applying knowledge, skills, analyzing stuff, evaluating information. Many of the things that you'll see as higher order skills on Bloom's taxonomy. Okay, but when we talk about critical thinking, the ability to use reasoning, where do we see that in our curriculum? Or we talk about problem solving, attempting to find a means of moving from the initial state to the desired goal. Problem. By problem solving, we're talking about anytime in a classroom in life there's a problem, it means I have a goal that I need to work towards. What is the mechanism or the means to solve that or reach that goal? That's a problem. That's a problem. Okay. And what we realize is that a lot of times teachers don't do a very effective job at helping students become problem solvers. Case in point, look at on the PowerPoint. I've given you um, two different problems. Okay, problem one, and they do this in the book too. Okay, using 4 straight lines, connect the 9 dots. Once you put your pen on the paper, you cannot lift it up. Okay, take a look at that. 9 dots. Take a look at that power on your slide. See if you can solve that problem. Okay. And you'll do the next problem as well. And that problem is, okay, and I have it written out in a PowerPoint. I have it written down. Time flies, period. I can't, they are too fast. Okay? And I ask you to describe the scene that is taking place there. And what you'll find in both of those problems is as students struggle with those problems, and I'm hoping you've worked on those problems, what is stopping you? What is standing in your way of success? And what we find is that in classrooms, in school, we learn from a very young age that the problems the teachers that we work with in classrooms are oftentimes very well-defined problems. What is a well-defined problem? Clear initial states, goals, and constraints with one correct answer. That means teachers teach at a very young age. 2 plus 2. Johnny has 2 apples. He gives Mary 1. How many does Johnny have left? Everything is laid out, spelled out for you for so many years. You just have to learn the process. Do exactly this, you get this one answer, right? Everything that you need to answer the problem is there. That is a well-defined problem. And students are fed well-defined problems for much of their school years. Well, unfortunately, life is not always so well-defined. Sometimes life, we encounter what they refer to as ill-defined problems. No clear goals, or may have multiple answers. For instance, teachers start asking questions as you get older, things like, we have a problem with teenage use of our teenage smoking or vaping. How do we fix that? Well, do you have the formula? Do you have the algorithm or the formula in place just to solve that problem? Because I don't. Okay? Substance abuse. A person gets in a fight with one of their friends or girlfriend or boyfriend or whatever else. Do you have a formula for solving that problem? No, I don't. Okay? Much of what we do outside of school is not always so well defined. It's very ill defined. Okay? They talk about things like pollution or the rainforest or killing of trees. Like, what's the answer to that? Do you have a formula? We don't. Those are ill-defined problems without a clear pattern or a strategy to solve that problem. And as a result, we have to learn how to approach it differently. Okay? So what we realize is that in much of classrooms, what we do, we teach kids a strategy teach the problems. They're very well defined with very clear goals, with a very clear answer. And as a result of that, they can apply a formula, they can apply a strategy, and they just work through the problem, and they get the answer. And then they get to a point, maybe even in third, fourth grade, and it's usually in third grade, teachers start doing these things called word problems in math. And some kids are like, oh my God, what do I do? What's the problem with word problems? For the first time, many times, students have to start writing the equation down themselves. They have to set up the problem themselves. They have to take words and from words create operations. So when they see the word, what is the difference? They know it's a math problem. What is the product? They know it's a multiplication problem, okay? What is the sum? They start using words to understand mathematical operations, and then they need to learn how to set up the problem. They struggle with that at first because they're so used to the teachers always setting up problems. Well, if we want our students to be problem solvers, we need to provide them not only the well-defined problems and the algorithms or formulas or strategies, we need to provide them instances to engage in ill-defined problems with no clear goals, with many possible answers, so that they can develop maybe heuristics or general problem-solving strategies that might lead to an answer. That's where they develop that true critical thinking, problem-solving skills. And what we find is a lot of times students will struggle. You go back to those problems with the 9 dots and the 4 straight lines. One of the problems that students and adults struggle with there is they try to create the 4 straight lines within the 9 dots. In order to be successful in that problem, you've got to take those 4 straight lines and take them outside of the 9 dots. But they feel constrained. They call that functional fixedness, that you become so fixated on one aspect, staying within the borders of the 9 dots, that you can't think outside of the box. Or the concept of the phrase, time flies, I can't, they're too fast. You get caught up, functionally fixated on the word or the expression time flies. Time flies when you're having fun, and they can't think about how that works in that phrase. Well, what I'm doing is there's 2 people sitting there. One person says to the other, time them, like with a stopwatch, time flies. Time them with your stopwatch, and they're like, I can't time flies, they're too fast. That's being functionally fixated on the expression time flies. And you can't think about it in another context. So the idea is we see that sometimes in problem solving that students get caught up in perhaps a response set, or they become fixated on an aspect of it, and as a result, it interferes with their ability to solve the problem. So as a teacher, we've got to give students opportunities to step inside and outside of a problem, and lots of experiences where they have to set the problem up themselves and come at it from different angles in order to develop those problem-solving skills. So the goal, again, is we need to facilitate learning in our classroom, developing the foundation, modeling, reinforcing, requiring that the students make multiple connections and to elaborate on content, and then eventually they take that knowledge base, are able to transfer it into other parts of their lives, and to approach each learning experience with a different set of eyes, with a different set of strategies or skills that will help influence their future learning experiences. If you have any questions over the content related to these videos or future videos, please make comments in the YouTube section or send me an email, and I'll do my best to explain that. Again, I hope everyone is doing well. Stay safe, and I will look for more a video about the case studies coming in this week, as well as an explanation of anything else that's going on in the class. Take care. Oh my God, I hope I was video. Oops, yes I was. Hello.